June 2012, Core 1, the last question, question 7. Increasing. First thing about increasing, we know is the gradient's going to be positive. So we're looking for this thing to be positive. So we want the y by dx to be greater than 0. So let's just write that out. 20x minus 6x squared minus 16 is greater than 0. Let's drag this around a bit. Let's put these minus x squareds on the other side. Let's take away the 20x's and add the 16. And so that's now going to be less than 0 because I've swapped them all over to the other side. And we could divide it all by 2, couldn't we? Dividing it all by 2 gives us 3x squared minus 10x plus 8. That's what they wanted, isn't it? To solve an inequality like this, we then need to actually factorise this thing. And being the last question, it's going to take us a couple of goes maybe to factorise this. It's negative here and positive there, so they're both going to have to be negative, aren't they? And I think it's going to be 4 and 2. Look, the 4 times the 2 makes the 8, and here we've got a 6 and a 4 to work out the other bit. So that must be lower than 0. Well, the crucial parts here are when does it equal 0? It equals 0 at 2 from there, and it equals 0 at 4/3 from there. Here's our sketch. We want it to be lower than 0. We want this bit down the bottom here. So we want it between those two values. So you put the x between those two values. There are 4 marks for that. The curve passes through a point, and we're now looking at the tangent. So tangents have got the same gradient. So at x equals 2, the gradient of the curve is the same as the gradient of this tangent. Let's find out what dy by dx actually gives at x equals 2. So we've got 20 times by 2 minus 6 lots of 2 squared, take away 16. So that's 40, take away, well, that's 4 times 6 is 24, isn't it? Take away 16. Wow, that gives 0. That gives 0. So if the gradient equals 0, then you can imagine we've got a flat line here, haven't we? Got a flat tangent, which is parallel to the x-axis. I wonder what the y value is when, oh, we've got the y value. The y value here was x equals 3, so we've got a tangent here at y equals 3, haven't we? 7 marks for the final part then. We've got another point here then. So when x equals 3, and let's find out what our gradient is when x is equal to 3 by dropping the 3 in. So we've got 60, take away 54, take away 16. And that gradient there now is minus 10. But we don't want a tangent this time, we want a normal. So our gradient is the negative reciprocal of that. We've got minus 1/10. And I think we're actually going to have to find it. So y, take away the y number. 1 minus minus 1. What's this? The 4th time we've done this on this paper. Y take away the y number equals gradient x take away the x number. It's not minus 10th. It's just 1/10. Sorry about that. That's times by 10. So I've got 10y plus 10 equals x take away 3. And what do we want? We want to find out, I don't think I needed to do that. We need to find out when they meet. Well, they meet when the y number is 3, don't they? Sorry, let's just go back a line. Let's just go back a line. If the y value is going to be 3, let's put the 3 in there. That just gives us 4 equals 1 over 10. Times by 10 gives me 40. And I think x is just 43. X is 43 where they meet. It does say coordinate, but we do know the y coordinate because the y coordinate is y equals 3. We put that in there. So 43 and 3 for that final bit. I hope I didn't go too wrong there. Here's the mark scheme, and here's the examiner's report. And here, for reference, is the marks needed for this one. We needed just 58 for an A on that one there. Usual 30 to pass.